so these are our notes that we're going to take about matter. We've discussed a lot of these things in class, but we haven't actually written anything down so that we have something to study when it gets close to time for the test. So when you look at this page, you'll see that there's a banner here in the middle. That's where the main thing is going to go. And so I'm going to write the word matter in kind of a makeshift font, just something quick so that we can continue without it taking too long. Looks like I ran out of the little room, but we'll make it work. Okay, so the word matter, okay? So over here we have a place to write the definition of matter. So matter is anything that has mass and volume. And volume had to go in that second spot because after it I put takes up space, which is the definition of volume, right? And so we had talked about how there are 4 different, sometimes you'll hear it say 3 different states of matter, 3 or 4, solid, liquid, gas, and plasma. Plasma is just an electrified gas. Then we also talked about things that are not matter. And things that are not matter include energy, for example, sound and light and heat and all of the other energies. Those are not matter. They don't have mass. They don't have a measurable volume. Some other things that you might include would be like thoughts or memories or dreams, which all technically are in your brain, but they are nothing more than electrical signals, so they are not matter. Matter can be divided into 2 main subgroups, and those 2 main subgroups are pure substances and mixtures, which are not pure, right? They're just a mixture of lots of different things. So a pure substance is something that is the same throughout because it's made of only one kind of particle. And a mixture is a combination of different kinds of elements or molecules or compounds, and they're not chemically bonded, so they can easily be physically separated. Okay, we're going to focus more on the pure substances first, and then we'll finish with the mixtures. So on the pure substances, if a pure substance only has one type of atom, we say it is an element. And if we have something that has 2 or more different types of atoms, we call that a compound. Now the confusion comes in the middle here. A molecule is 2 or more atoms that are chemically bonded together. They could be the same atom or they could be different. So a molecule could be what we call an elemental molecule, or it could be a compound molecule. And so sometimes there's a little bit of confusion over what are we talking about, okay? So all compounds are molecules, but not all molecules are compound molecules. Some of them are elemental molecules. So molecule just means 2 or more atoms chemically bonded together. Let's go to the easiest one first. Let's look at elements, okay? if we were to draw some circles to represent one type of atom from the periodic table, for example, these, and maybe we labeled them with a capital N, which if you look on your periodic table, you could find that N stands for nitrogen. Notice none of them are touching, none of them have a stick attaching one to the other. This is just nitrogen atoms. There's one type of atom, right? There's one color. There's one capital letter, right? All of them are capital N's, okay? So this is an element. An element can be found in the boxes on the periodic table, okay? If we were to talk about an elemental molecule, then we might draw two of the same type of atom and connect it with a bond. That stick in between represents the chemical bond. I'm going to label each of these with an O because they're going to represent oxygen, or O with a little 2 as a subscript. So the 2 means there's 2 of them and they're bonded together. Okay, so that's what we breathe, is elemental molecules of oxygen. Okay, nitrogen would just be written with a capital N, no number. Okay, it just means this is an element, this is an element, this is an element, they're all the same type. Here, they're both the same type, but they're bonded together, and there's more than, there's 2 or more than one, right? So this is an elemental molecule. This is an element. But a lot of times, we end up shortcutting, and we say that anything that is just one type of atom is called an element. So you'll hear this called an element, but you'll also hear this called an element because there's one type, one color, or one capital letter, right? Now, a compound is 2 or more different types of atoms that are chemically bonded together. And so I could have one molecule of carbon, and it could be bonded to 4 hydrogens. So I'm going to put capital H's on each of these. And I'm going to put a capital C on that one. This is actually CH4, or methane gas. That was always my son's favorite chemical. That's the chemical formula for a fart. So methane gas. CH4, 1 carbon, 4 hydrogen. These are 2 or more different types of atoms that are chemically bonded together. So it qualifies as a molecule because it's 2 or more, but it qualifies as a compound because they're different. They're not all the same. So if we were to draw an example down here of yet another compound, we might draw an oxygen again, and then we might bond 2 hydrogens to that oxygen, and now we have H2 because there's 2 of them, and then O, there's one of those. So H2O, which is water. That is a compound, which is a pure substance, right? Because these are different types of atoms, but they're chemically bonded together. So all of them would be looking like this in the glass, right? You can't see them, but if you could. All right, we're going to get rid of this as our example because we're just going to start classifying them as elements and compounds. So if we were looking for some examples of elements, you might see capital H, little e, which is helium. That's an element. You can find it on the periodic table. If you know any welders, they might use argon. That's an element. You can find it on the periodic table. You might also see hydrogen written as capital H with a little 2. The gas hydrogen, that's how it is in the air. You could also look for, let's go ahead and put our O2, which is oxygen. All right. So these two are technically elemental molecules because there's more than one atom, but they're the same. These are technically elements, but most of the time you'll hear all of these called or classified as elements. And then when we look at our different compounds, of course, we could put water, which is H2O. We could include things like carbon dioxide. Di means 2, so CO and a little 2. That means there's 1 carbon and 2 oxygens. That's what plants need to do photosynthesis. And then plants produce something called glucose, which is C6H12O6. That's a whole lot of atoms that are different that are bonded together. Okay, so those are our pure substances. Now we're going to look at our mixtures, which is another type of matter. Matter that has a combination of different kinds of elements or different kinds of molecules or different kinds of compounds, and they're not chemically bonded, so you can easily separate them. This one says it contains 2 or more substances that are physically combined and appear to be the same throughout, okay, the mixture. We call this a homogeneous or homogeneous. You can pronounce it either way. The prefix homo means same, right? And a great example of this is one of my favorite things. We're going to draw some particles here that are evenly spaced throughout our solution, so that if you tested the top, you would get exactly the same amount of sweetness as if you tested the bottom. So each of these little circles represents sugar, and in between them, we're going to have a wonderful brown like liquid that is tea. All right, so sweet tea tastes the same at the top of the glass as it does at the bottom of the glass, and when you look through the side, it looks the same throughout. And because they have dissolved, which is physical change, dissolved the sugar into the tea, you end up having what we call a homogeneous or homogeneous mixture. Now, it just so happens there's another name for homogeneous or homogeneous mixture, and that is that it's called a solution. Okay, so that is our the tea and the sugar. The sugar is all the way through the liquid. It's the same at the top as it is at the bottom. So another name for a homogeneous mixture is a solution. All right, some examples. Another one, when you go to the store and you buy milk, it's homogenized milk, meaning that it doesn't separate into the cream and the milk. It's all the same. So it is homogeneous. Okay. Salt water is another example. You go to the beach and you get some salt water. The salt water is the same amount of saltiness all the way through it. All right. Now, if you have a mixture that is not the same all the way through it, we call it a heterogeneous. And hetero means different. So it has the two or more substances. They're still physically combined, but they're not the same throughout, okay? If I were to get a jar of water and sand, I could see the sand at the bottom and the water at the top. If I were to have a bowl of salad, I might have some lettuce, lots of lettuce. I might have some tomatoes. Right. I might have some croutons. Might have some cheese, whatever. Okay, I got all this stuff in here, right? And here's some cheese. Now, every time I stick my fork into the salad, if it was the same throughout, I would get exactly the same things on my fork in the same proportions, the same ratio. A salad is not like that. Sometimes you get the tomato, sometimes you get a cucumber, sometimes you get a crouton, sometimes you don't. You're not always going to get the same thing. It's not the same throughout. So a salad is a good example of different or heterogeneous mixture. Water and sand mixed together because the sand's going to fall out at the bottom. Oil and water. If you've ever had a vinaigrette dressing on salad, you know that if you let that jar stand or sit for a little while, it starts to separate into different layers. It's not the same throughout. And so that's what we're talking about when we talk about these heterogeneous mixtures. So now let's take a look at your